Welcome to Should Have Known It, where we present 15-minute shows of things you definitely should know. Hi, welcome to Should Have Known It. I'm Mr. Whitfield, and today's topic is the probability of being wrong. The human mind, it turns out, runs on a kind of binary update system by default. A belief is either confirmed or it isn't. Evidence either proves something or it doesn't. This is psychologically comfortable. It means you never have to sit with the discomfort of being partially convinced. But it is not how probability works, and it is not how rational belief revision works. Here's a concrete example. Suppose you believe with some reasonable confidence that a particular colleague is competent at their job. You've seen them handle 3 projects well, then you watch them fumble badly on a 4th. The all-or-nothing mind says, I was wrong about them, but that conclusion is too fast. 3 data points and 1 disconfirmation don't cancel each other out. The evidence should move your confidence, but not to 0. So what is the alternative? The alternative is to hold your beliefs as numbers rather than verdicts. Not I believe this or I don't believe this, but I believe this with roughly 80% confidence, and then to ask honestly, given this new piece of evidence, what should that number become? That is the Bayesian discipline. It is less a mathematical formula than a habit of mind. Thomas Bayes was an 18th century English minister who in his spare time thought carefully about probability. He died in 1761 having never published his key result. It was found in his papers afterward and published by a friend. The theorem named for him answers one precise question. If I already have some belief and I observe new evidence, how much should my belief change? The formal version involves multiplying prior probabilities by likelihood ratios, and we will do none of that arithmetic today. What I want you to take away is the structure of the question itself. You begin with a prior, your existing confidence level before the new evidence arrives, and you end with a posterior, your updated confidence after. Every rational belief update has this shape, whether you run the numbers or not. What Bayes proved is that the update should be proportional. If the evidence is only slightly more likely given your belief than given its alternative, your confidence should nudge a small amount. If the evidence is enormously more likely under your hypothesis than under any other, your confidence should jump substantially. The size of the update tracks the strength of the evidence, elegantly, inevitably proportional. Here is where people resist. They hear prior belief and they think bias. They think prejudice dressed up in mathematics. And it is true that priors can encode prejudice. But here's the crucial point. Ignoring your prior is not objectivity. Ignoring your prior is just a different kind of error. It means treating every new piece of evidence as if it arrived in a vacuum, as if nothing you ever learned before this moment counts. In 1983, a study by Kahneman and Tversky presented subjects with a description of a woman named Linda, politically active, philosophy graduate, deeply concerned with social justice, and asked whether it was more probable that Linda was a bank teller or a bank teller who was also a feminist activist. Most people chose the second option. This is called the conjunction fallacy. A conjunction of 2 things is always less probable than either one alone. The vivid story overwhelmed the prior probability. The prior is not baggage. The prior is your accumulated evidence from before this moment. If you've watched 1,000 sunrises, your prior probability that the sun will rise tomorrow is extraordinarily high, and a single cloudy morning should not shake that. The new evidence gets incorporated. It does not get to erase everything that came before. That is the whole discipline in one sentence. Let me introduce one more term, because it earns its keep. The likelihood ratio. When new evidence arrives, the right question is not, does this evidence support my belief? The right question is this evidence more likely if my belief is true than if my belief is false? That ratio is what does the updating work. Evidence that is equally likely in both cases, whether your hypothesis is true or not, should move your belief exactly 0. Here's the medical example that illustrates this beautifully. Suppose a screening test for a rare disease has a 99% accuracy rate. The disease affects 1 in 10,000 people. You test positive. Most people, including in documented studies, most physicians believe this means you almost certainly have the disease. The actual probability is roughly 1%. Why? Because the disease is so rare that even with a highly accurate test, most positives are false positives. The prior, that 1 in 10,000 base rate, carries enormous weight. This is not a trivial academic point. In the early days of HIV screening, before anyone understood base rates, positive tests caused devastating false certainty in low-risk populations. The test was accurate. The inference was wrong because someone looked at the evidence and forgot to ask, accurate compared to what prior probability. The likelihood ratio was strong, the prior was weak. People ignored the prior entirely. A piece of evidence with a likelihood ratio of 10, meaning it's 10 times more likely if your hypothesis is true than if it's false, is genuinely substantial. A likelihood ratio of 1.2 is barely worth noting. Learning to feel the weight of these ratios intuitively is more practically useful than knowing the formula. Let me tell you about a pattern I see constantly. Someone holds a political or scientific belief with moderate confidence, say 65%. A commentator on the opposing side says something foolish, and the person immediately jumps to 90% confidence in their original position. But wait, what was the likelihood that the opposing commentator would say something foolish regardless of which side was right? Quite high. The evidence, one bad argument from the other side, has a likelihood ratio barely above 1. It should move your needle almost nothing. The philosopher John Stuart Mill understood this intuitively in 1859, which is why in On Liberty, he insisted that every serious thinker must be able to state the opposing view better than its proponents do. Not because the opposition is right, but because a weak opponent proves nothing. Beating a bad argument tells you almost nothing about whether your position is correct. The Bayesian version, the strength of the evidence depends on what it would look like if you were wrong, not just what it looks like when you're right. So here is the discipline in practice. Every time you encounter something that feels like confirmation, ask, would I expect to see this even if I were mistaken? If yes, dial back your update. If a new fact would be equally surprising under both your belief and its alternative, it has contributed nothing. You have simply enjoyed the feeling of confirmation. That feeling is not a data point. Now, the opposite failure mode, anchoring, is when a prior becomes so entrenched that no amount of evidence moves it. The philosopher's term is epistemic stubbornness. The Bayesian term is a prior so strong that the likelihood ratio of new evidence can never overcome it. In practice, this is usually not a mathematical problem, it is a psychological one. The prior has become an identity. Consider the scientific case of Barry Marshall. In 1984, Marshall proposed that stomach ulcers were caused by a bacterium, Helicobacter pylori, rather than by stress or excess acid. The medical establishment's prior on this was so strong, everyone knew ulcers were caused by stress, that the evidence Marshall presented was dismissed for years. He eventually drank a solution of H. pylori himself to prove it caused gastritis. He won the Nobel Prize in 2005. 20 years of anchoring cost countless patients proper treatment. The diagnostic question for anchoring is this: what evidence would actually change your mind? If you can't answer that, your belief is no longer a probability estimate, it is an axiom. And axiomatic beliefs are, by definition, immune to evidence. That is not strength. That is a closed system. Bayesian thinking requires you to pre-commit to what would move you before the evidence arrives. And then there's the other failure, which is almost the mirror image: wild overcorrection. One striking piece of counter-evidence arrives and the entire prior collapses. This is especially common with emotionally charged evidence, a personal story, a vivid anecdote, something that happened to someone you know. The availability heuristic, Kahneman's term, means we weight vivid evidence far above its statistical frequency. Vaccine hesitancy has this structure at its core. In 1998, Andrew Wakefield published a fraudulent study in The Lancet linking the MMR vaccine to autism, a study involving 12 children, later fully retracted, its author stripped of his medical license. And yet for millions of parents, this single dramatic anecdote overrode decades of epidemiological data from hundreds of millions of vaccine doses. One powerful story achieved a likelihood ratio in those parents' minds that the actual numbers never could. This is Bayesian failure in the overcorrection direction. The prior wasn't merely revised, it was overthrown. And this is the genuinely strange thing. Emotionally vivid evidence is not stronger evidence. It is more memorable evidence. Those are completely different properties. A single heartbreaking story about a child experiencing symptoms after vaccination is not more statistically informative than a meta-analysis of 40 randomized controlled trials, but it feels like it is. Every Bayesian update should be proportional to the actual information content of the evidence, and a story's emotional power is not its information content. There is a practical skill that emerges from all of this, and it has a name: calibration. A person is well calibrated if, among all the things they claim to believe with 70% confidence, roughly 70% of them turn out to be true. Philip Tetlock, the political scientist, spent 20 years tracking the predictions of expert forecasters for his 2005 book, Expert Political Judgment. What he found was that most experts were badly calibrated, overconfident in their domains, unable to update when early predictions failed. The best forecasters in Tetlock's later super forecasting project shared a specific habit. They expressed beliefs in probabilities, they updated frequently as new evidence arrived, and they were willing to revise even when revision felt like admitting weakness. They treated "I changed my mind because the evidence changed" not as an embarrassing flip-flop, but as the whole point of the enterprise. That reframing from changing your mind as weakness to changing your mind as the evidence working is the core psychological shift. And here's the number Tetlock found for prediction accuracy over political events at one-year horizons. The best calibrated super forecasters outperformed CIA analysts with access to classified intelligence. Not slightly, substantially. The discipline of thinking probabilistically, of making beliefs explicit enough to be updated, was worth more than secret information. That is the payoff of Bayesian thinking rendered as a real finding with real numbers. One last nuance that is worth your time: not all priors deserve equal weight. A prior that is itself the product of extensive reliable evidence should be very difficult to move. A prior that you acquired by osmosis, from the culture you grew up in, from the first thing you ever read on a subject, from a teacher you trusted at age 15, is much softer and should yield more readily to good contrary evidence. The question to ask about any strongly held prior is, why do I have this prior? What is its own evidential basis? The physicist Richard Feynman put it in characteristically blunt terms. The first principle is that you must not fool yourself, and you are the easiest person to fool. The ways we fool ourselves in belief formation are well documented. Confirmation bias means we seek evidence consistent with existing beliefs. We weight hits more than misses. We remember the predictions that came true and forget the ones that didn't. A calibrated Bayesian has to run against these instincts deliberately, consciously, every time. But here's what makes this worth doing. When you hold beliefs as probabilities, when you update them proportionally, when you can say, "I was 70% confident and now I'm 40% confident, and here is exactly why," you become someone who is genuinely learning from experience, not just accumulating it. Most people accumulate experience without updating. The Bayesian discipline turns lived experience into actual knowledge. That distinction is enormous. Let me bring this all the way down to the practical level, because I don't want to leave it in the abstract. In ordinary conversation, Bayesian thinking sounds like this. "That's interesting. That shifts my view a little." Not "you've convinced me," and not "that doesn't change anything." The middle response, the proportional response, is almost never what people say. It's worth practicing because saying it out loud forces you to actually locate your belief on a scale rather than treating it as a binary switch. It also changes how you argue. If someone presents evidence you hadn't considered, the Bayesian question is not, "Does this destroy my position?" but "How much weight does this carry?" You can acknowledge that a counter-argument has genuine force. You've moved me from 80% to 65% on that point without conceding the whole debate. This is not hedging, this is precision. And strangely, it is more persuasive to your interlocutor than digging in because it signals that you are actually engaging with what they said. The hardest version of this, and I want to be honest about it, is updating beliefs that are bound up with identity. What we believe about ourselves, our communities, our choices, these have priors that are almost social contracts. To lower your confidence in one of these beliefs is to risk something beyond being wrong. And so we dismiss. We overcorrect back to certainty. The Bayesian discipline breaks down exactly where it is hardest to apply. I won't pretend otherwise. Here's what I want you to carry out of this room. You don't need the formula. You need 3 questions. First, what is my current confidence level as a number, not a word? Second, is this new evidence more likely if my belief is true than if it's false? And by how much? Third, what would it take to actually change my mind? If you can't answer that third question, your belief has stopped being a belief and started being a wall. These are not always comfortable questions. The Bayesian discipline is, at its core, a discipline of uncertainty. It asks you to live with partial confidence as a permanent state, not a temporary inconvenience on the way to certainty. For most of us, trained in educational systems that reward definitive answers, this requires a genuine habit change. But the alternative, certainty maintained by ignoring evidence, is a significantly worse place to be. The great statistician George Box wrote that all models are wrong, but some are useful. The Bayesian model of belief isn't a perfect description of how human minds work. It's a useful correction on the ways they go wrong. Hold beliefs as probabilities. Update them proportionally. Notice when you're refusing to move? That's not the math. That's the discipline. And the discipline is everything. I'll leave you with that. Think about one belief you hold strongly and ask whether you could Actually name what evidence would shift it. That single question, taken seriously, is the beginning of the whole practice. Good night.
And that brings us to the end. Thank you for joining me. I hope you learned something new. Until next time.